Hello everyone. In this video we're going to be solving a polynomial equation. This is a very special polynomial. You're going to know why in a little bit. I'm going to be presenting two methods, and almost as always, let's start with the first one. Now my first method is using factoring by grouping. So I want you to notice that x cubed plus 1 can be factored. X cubed plus 1 is called sum of two cubes, and sum of two cubes can be factored. This can be factored into x plus 1 multiplied by x squared minus x plus 1. If you want to know what sum of two cubes is, a cubed plus b cubed can be written as a plus b multiplied by a squared minus ab plus b squared. That's the formula I used here. Now, why did I mention that? Because if you look at the equation very carefully, you're going to notice that you can break it down to make it factorable. So my polynomial is x cubed plus x squared minus x plus 2, but it can be written as the sum of two polynomials that have a common factor. What is it? It is x cubed plus 1 and x squared minus x plus 1. So what I did was I broke down the 2 into two pieces, and that gave me two polynomials or two pieces with a common factor. Great. So now I have the x cubed plus 1, which can be written as x plus 1 multiplied by x squared minus x plus 1. Again, it is from sum of two cubes. We just talked about it. And x squared minus x plus 1 is a prime polynomial, which means you can't really factor it, but you can always write it as 1 times itself. Great. So now I do have a common factor because x squared minus x plus 1 is a common factor. Therefore, we can factor this by grouping. So I can take out x squared minus x plus 1, and then I will take the x plus 1, and that's just going to give me x plus 2. Awesome. Okay, great. So that gave me two factors, one linear, one, what is it called? Quadratic. I just forgot the name of it. And by setting this equal to 0, we can find the solutions very easily. X plus 2 equals 0 means x is equal to -2. That's one of the solutions, and that is the only real solution because the other solutions are going to be complex. You probably recognize this number here. If you use the quadratic formula, so set this equal to 0, solve by using the quadratic formula, you're going to get -b plus minus the square root of -3 divided by 2, which can be written as 1 plus minus the square root of 3 times I divided by 2. I is the number whose square equals -1. All right, great. So these numbers are special because if you think about x squared minus x plus 1, when it's multiplied by x plus 1, then it becomes x cubed plus 1. So by setting it equal to 0, you're basically finding the cube roots of -1 because this equation is equivalent to x cubed equals -1. Obviously, we have to add the condition that x does not equal -1 because we don't have that. We only have the quadratic. So that means we are looking at the complex cube roots of -1. And we are excluding -1 itself, of course. And those numbers can also be written in polar form. So x can also be written as cosine pi over 3 plus I sine pi over 3 for my radian friends. And then the other solution is just going to be cosine of 5 pi over 3 plus I sine 5 pi over. If you look at the unit circle, you're going to know what I'm talking about. But you could also write this as x equals cosine of pi over 3 plus minus, if you don't want to deal with a large angle, just want to keep it small, you can also do it that way. All right, great. So now this is the first method. Let's go ahead and talk about the second method. All right. The second method is obviously a different idea, and I'd like to introduce that to you as well. X cubed plus x squared and I'm hoping that someone will find the third method, maybe Cardano's formula or something else like that. Okay, so my second method uses the rational root theorem. What is that? Now, rational root theorem says if there are rational roots, and of course there may not be, in this case we do know there is, but suppose pretend that you didn't know the answer. So rational root theorem tells us that if we have rational roots, then since this is a monic polynomial, meaning that the coefficient of x cubed is 1, the roots have to be divisors of 2. We only have like 4 possibilities, plus minus 1, plus minus 2. So we're going to look at those candidates. So let p of x equal x cubed plus x squared minus x plus 2. Then p of 1 is equal to 1 plus 1 minus 1 plus 2. That does not equal 0. Too bad. P of negative 1 is equal to negative 1 plus 1 plus 1 plus 2. That does not equal 0 either. P of 2 is equal to 8 plus 4 minus 2 plus 2. That does not equal 0. And finally, P of negative 2 is negative 8 plus 4 plus 2 plus 2. And that is equal to 0. Yay, finally. That means that x equals negative 2 is a solution. And that means x plus 2 is a factor. Since we know that x plus 2 is a factor, of course, the factor theorem tells us. The rational root theorem tells us the root, and then the factor theorem tells us what the factor is going to be. And since x plus 2 is a factor, I can just go ahead and, take my original expression and arrange it in a factorable way. And the way to do it is, since I want x plus 2, I'm adding 2x squared to it, because now notice that this can be factored, and one of the factors will be x plus 2. But then I kind of have to balance out, and then of course this needs to be followed by negative 2x. That indicates that I have to add an x and then a 2, and everything will be balanced. Now I can factor by grouping, and everything will be awesome. Okay. Now from here, x plus 2 is a common factor, as you know, because that shouldn't be a surprise. We know that it is one of the roots is x equals negative 2. And this basically brings us to the same point, and we get the same answer as before. All right? And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.